This presentation is a guide to jumpstart Scala development starting from a Java background. Here we focus on the syntax differences between Java and Scala. Of course, here Java knowledge is taken for granted. As a consequence, unless you already know Java, you may not be able to understand this presentation. You should assume all the code in the samples is Scala code, unless stated otherwise. Since we will compare, some Java code will be provided. If it is Java, then a comment will state it. Let's start our journey looking at declarations. First step is learning how to declare variables and constants. Afterwards, we will see how to declare methods that generally belongs to a class. Finally, we will examine how classes are declared in Scala. Let's start with variables. Here I am declaring first an integer variable in Java, second a string constant. Here is the equivalent Scala declaration of an integer variable. As you can see, the most important difference, I placed the type after the variable, separated by a colon. Note I have to precede a variable declaration with the var keyword. Likewise, if you want a constant, you have use instead the keyword val. This code is declaring a string constant initialized with the given value. Note how I am using the val keyword to declare I cannot modify the value anymore. The Scala code we wrote looks longer than the equivalent Java code. Scala, however, most of the time allows omitting the type declaration. The compiler can deduct the type of the variable automatically. Using the type inference, you can omit the type declaration. The compiler, just seeing the integer 1, can decide the variable type is actually integer. The same holds true for the second example. Here we are instead a constant of type string. The type is deducted from the string constant. You may have noticed in Scala code there is not a semicolon at the every declaration. Indeed, semicolons are not required because Scala can infer it from the source code. In the simplest case, an end line ends statements, but only if they are complete statements. This is important. However, as you can see in this example, a dangling plus does not end the statement. Scala infers the statement is not complete, so it looks at the next line for the rest. This feature is actually pretty handy for splitting long statements over multiple lines. Let's see now how parametric types are managed. We start with a classical list parameterized to contains only strings. You can write equivalent Scala code just replacing the angle brackets with square brackets. Of course, we have also to apply the changes we already discussed and use an appropriate class. Here is how we can write the declaration using type inference. Now it is the turn of examining methods. Here you can see a simple Java method declaration. It is named sum. It takes two integers and of course it returns the sum. Here is the Scala version. The first difference you may notice is you need the keyword def to precede the method name. As we did for variables, the parameter type follows the parameter name in the parameter list. Also the method type follows the parameter list, separated by a colon. Note the function body is separated from the declaration by an equal sign. Finally, you do not need to say the method is public. Indeed, public is the default visibility, so it does not need to be explicit defined. The initial can actually be simplified a lot using Scala rules. You do not need to specify a return statement. The return value is simply the value of the latest expression. Generally, but not always, we do not need to specify the type of the method. It is inferred from the type of the latest expression. Finally, when the body is a simple expression, braces around the expression are not required. Note we do need to specify the type of the parameters. Type inference cannot decide the types of the parameters you want. It is your decision what the function needs to receive an input. A special case occurs when a method does not return any value. We say then it is a procedure. A Java void type translates in a Scala unit. Actually, a unit is an empty tuple, as we will see later. We use this value as the return value when there is not any result. Also, this code can be shortened. I can declare that a function is returning a unit just omitting the equal sign. In this case, however, braces cannot be omitted. Now we can consider some more complicated examples related to classes. Here is a simple Java class with a single field, name. Note the name is actually calculated concatenating the first name and the surname. There is a constructor which receives two parameters and produce the actual value of the field. Here is the equivalent Scala code. As you can see, the declaration of a class in Scala looks like just the declaration of its constructor. The code looks like a procedure, but you use class instead of def. Note the body of the class can contain generic statements, not just declarations. In Java you can only have declarations. A class constructor must be executed prefixed by the new keyword, as in Java. All the variables created in the body are persistent and available as fields. Here is a common idiom in Java. We create a class with two fields, and we initialize them with parameters with the same name. In Scala this code is simpler. Just use the prefix var for each parameter and the parameters become fields without the need of having to copy them. Another common idiom in Java is the getter pattern. To create a read-only field, you define a private field and a getter to read it. Then you initialize the field with a constructor. This pattern is much simpler in Scala. Just define a parameter as a val. It can then be read, but the compiler will refuse to compile code which changes it.